Welcome everyone to the Python programming sessions. In this session, we are going to understand Python modules and packages. So let's try to understand what are Python modules and packages. What are modules in Python? A simple .py file. So when we create a .py file, it is actually a Python module. Name of the module is same as the name that you give to the .py file. So if I create a module abc.py, in that case abc is the module name. I hope all of you are getting this. Whatever file name you give in Jupyter notebook, what we have is basically IPython notebooks. However, we can save it as .py file also. So how do we save it? Basically, you will have to go file, save as, or sorry, cancel, file, download as. In that case, you have a extension .py. So that's how using Jupyter we can create a py file also. Okay. What does a module? What do you mean by a module? See, if I have to create an application, in that case, the entire application is broken down. It's broken down into smaller modules, smaller components. For example, if I have to build a banking application, in that case, the entire banking application, you will have to break down into smaller components. One of the smaller component would be registering a new customer. So you will have a module customer registration. If a customer registers, after that there can be modification in the profile of the customer. So you will have a module customer modification or alteration. Having opened a customer, having registered a customer, what does a customer buy? Customer buys a product. In a banking case, he may buy a savings account, a loan, a mutual fund, an insurance. So you will have different modules for each of these products. So in that case, you do not end up writing the whole logic in one big code file saying banking application dot py, whatever. I hope you all understand the concept. So you break down the work into smaller tasks, and for each task to be accomplished, you create a separate code file of it, and that code file is a module. Sometimes what may happen is, for a particular task, you may further break into smaller tasks, smaller components. The lowest granularity is the module, and the sum total of all modules which help you accomplish a particular purpose becomes a package. Okay, so this is the concept of module and package in general for any programming language. Same terminologies are being used in Python. Does it make sense? So here we have got this, so that for me to understand that you have understood the concepts, what is a module and what is a package, I would like you to type down these on your Jupyter notebook. And while you type down, you have to ensure you use proper markdowns. This is in very highest font. This is highest font. Then this font is smaller. So some heading levels, header 1, header 2. So in that case, you have to type it down. Let's start with the Jupyter notebook, because it is very important for you to be very comfortable using Jupyter notebook also. We'll now create our first module by the name myfirstmodule.py. I'm more comfortable creating py files using Spyder. So I'll be using Spyder for my interface. Now, yesterday we saw how to go about launching Spyder. Today we are going to see one more way, which is Anaconda Navigator. So here you see there is something called Anaconda Navigator that comes up. So let's start Anaconda Navigator. All of you launch your Anaconda Navigator. So it says, do you want to install? No, don't show again, no, remind me later. My Anaconda Navigator has been launched. So here you can see there are many apps. It says Jupyter Lab, Notebook, IPython, Qt Console, Spyder, and many more things. Orange. Orange is a graphical user interface for building machine learning models. Okay. Then RStudio, VS Code, and so forth. For now, I want Spyder. So I'll click on Spyder. Launching Spyder. Here you see launching Spyder. So we have our Spyder launched. I'm now going to open my first file which I have already created. Okay, I'll just create a new file here. It is untitled 0.py. I'll save it as first. I'll give it a name, save as, and I'll save it in appropriate path. Always ensure whenever you work, you should save it in your appropriate path. Yesterday we created my first notebook. Today we are going to create my first module, and I'll give the extension .py. Save. And we'll have 3 lines of code which I have already given here. So I'll just copy that. I will uncomment these 3 statements. And I'll save it. Okay. Where I have saved it? I have saved it in DK2 Analytics, my first module.py. I am closing it. I am closing this file. Now I come back to my IPython notebook. We have used import statements. Probably yesterday we would have used it. If not, now we are going to use the import statement. I'm now saying import my first module. Okay. This statement here it shows is error, but this statement now it is not going to give me error. If you would have saved it in a path, say D drive or D Python programming, some other folder, in that case it would give error. But in this case it is not going to give error. Why? Because I have launched Jupyter Notebook from DK2 Analytics, and DK2 Analytics is now in my system path. Because it is in system path, automatically it will see all path which is in the path setting. So as such it should not be giving error. As such it should not be giving error. I'll show you by launching another Anaconda prompt, or not by launching another Anaconda prompt. Where is that? My first type. This is my first module.py. Control C, new folder, Python module path setting. Okay, and I'm copy pasting this file here and renaming it. My first module renamed. Okay, let us run the same import renamed. I get the error. Why I get the error? Because DK2 analytics and the folder that we just created, that folder is not in the path setting. That's why if you create your own module, if you create your own library, you typically do not save your modules and libraries in the folder where Python Anaconda would have installed. You should not disturb that folder setting. You should create your own custom folder, and that custom folder you should put in the path setting, and any package now you create will get loaded because that is in the path setting. Does it make sense? And how do I know path setting? Any point of time, if you want to know the path setting, you import sys and say sys.path. We launched Anaconda from DK2 analytics, and yesterday we had set system path also. So that's why it is coming 2 times. I hope the path setting concept is clear and module concept is clear. Okay. In case you do not want to go into the environment setting folder, but you want to just set the environment for your current execution, how you go about doing it. So in this case, I created this new folder path. So I take this, I put here system.path.append, and note that when you work with Python, you do not use backslash, you use /. So we'll make this /, and the file name we gave was my first module renamed. So I now give it my first module renamed. If I now run this command, it should not give me error. Why? We appended the path setting. Making sense? If I say print XYZ, it gives me error. X, Y, Z were the 3 variables which we created in the file. DK2 analytics, X, Y, Z we declared here. I imported the module, which means X, Y, Z should be available. I imported the module, that's why X, Y, Z should be available to me. However, when I run this, it says X, Y, Z not available. Variables declared in a module can be accessed only by prefixing the module name. So how do I access it? I have to say my first module.x, because if you are just simply saying x, it may so happen I say x is equal to 1, y is equal to 2, z is equal to 3, print xyz, it is now going to print 1, 2, 3 because xyz we have declared now. But if I want to access xyz which is in the module, to avoid conflict between xyz which you have just declared and the xyz which is in the module, you have to prefix the module variables by the module name. So here, if I have to access XYZ of the module, I'll have to say my first module dot X, my first module dot Y, and my first module dot Z, and I get 10, 20, 30, which is from the module now. So we just saw print statement, and we saw that 10, 20, 30, we have accessed the variables X, Y, Z from my first module. If I just type my first module, you will see the output coming as module, my first module, and from where it is taking. It is taking from DK2 Analytics, my first module.py. So it is giving you the path from where it has got the file. We will now understand the concept of namespace. Namespace in programming language is used to set the context and correctly locate functions variable without ambiguity. What I mean to say you have got two modules. One module is named as rectangle, other module is named as triangle, and both the modules has got a function compute area. Now I have imported a rectangle and I have imported triangle, and I want to call the function compute area. Which compute area function to be called? Whether it should be rectangle or whether it should be of the triangle. To resolve this ambiguity, any programming language has a concept called namespace. And that concept of namespace is you prefix the function name by the module name. So if I say rectangle.compute area, there is no ambiguity. The compute area has to be called from rectangle. And if I say triangle.compute area, again there is no ambiguity. The compute area has to be executed from triangle. So this is the namespace concept. Now how the concept of namespace is implemented in Python. Namespace in Python are maintained in Python dictionaries. What is a dictionary? Dictionary is a key value pair. So when you create a module will have attributes, variables, functions. The module name will become the key, and all the attributes, all the functions present in it will become the values. So when you now call a function from a given module dot something, it immediately looks into the dictionary to see whether it is available or not available, without actually parsing the whole content of the code file. By quickly going to the dictionary, it comes to know whether the call is a right call or a wrong call, and from that it can quickly execute the code. So this is where the namespace concept comes in. Now there are three types of namespaces in Python. One is called a built-in namespace. The built-in namespace is created when the Python kernel is started. What is a kernel? The console that you have in which the code is actually executed, behind there is a kernel. Kernel is basically the shell in which all the code gets executed, all the work is happening. That shell is called the kernel. So when you launch the Python, the built-in namespace is created. In a built-in namespace, all modules, all variables that have to be default loaded at the time of startup goes into that. Second is a global namespace. When we import a module. Uh, that module actually goes in a global namespace. So when we imported my first module will go into global namespace. So the first is built-in namespace, which all the core components will go. The second layer is global namespace, and the third layer is the local namespace. Now, what is a local namespace? I have a module in which there is a function compute area. The module name is rectangle. It has got a function compute area, and that compute area internally has a variable, say length and breadth. The variable which is declared inside the function, that variable will be only available inside the function only. It cannot be accessed outside. That is called the local namespace. The access of variables declared in a function is very localized to the extent of that function. Beyond that, it does not have any existence. So that is called a local namespace. So three types of namespace: built-in, global, and local. Any modules we load will go in global. What gets loaded by default when you start is built-in. And in your module, if you have functions, anything which is inside the function will become part of local. This is used by any and every programming language. Same concept you would have come across if you work on R programming. Same concept you will come across if you use Java programming. So this is universal. Okay. So let me explain this with an example. In our first module, we had created a variable pi. So if I have to access the value of pi, I have to say my first module.py. If I run shift enter, this is the value I get. The same variable pi is actually part of math library also. So I import a math library and say math.py. Can you see the difference? This is 3.142 because we declared pi as 22 divided by 7, and the actual value which is there is 3.14159, which is declared in the math. Intentionally I declared approximation so we can see the difference in the two values. So from here it is very clear the first pi is coming from the math, my first module. The second pi is coming from the math module. In this case, math and my first module are the namespace, which means the module name also becomes the namespace name in the global namespace area. We now discuss more about packages. Okay, my pi value, before getting into packages, let me just correct my pi value in my first module. So I go back to my Spyder, and here is my first module. I'll put one more line, pi is equal to the value which I have copy pasted, and I save it. Having saved it, I come back to my Spyder, and I'm now going to say import my first module. So I would like to import this, shift enter, and I want to see the value of pi. So here let me just add print my first module dot py. Shift enter. It is still reflecting the old value only, despite I have made the changes in the file. In order to reload, we may have to, what is happening is the module file we changed, but it was already loaded. As such, the reload by import statement is not working. In that case, we'll have to import a package imp. Having imported the package, we'll have to run imp dot reload function, and in reload function, which module you would like to reload, you have to mention that, and then the module will get updated. Having updating the module, we can now access the changed py value. This time it has got changed. So the point is, if you have loaded a module and later on in the background you are changing the module will not get loaded. In order to ensure the module is loaded properly, you will have to use a package imp, and with imp.reload you will have to reload the module. Only then the changes will reflect. Okay, let's move on to the package concept. Packages provides a systematic organization of a module. I want to do a data analysis. Now when you want to do a data analysis, the way it happens is you start with import of data. So you would have raw data. So you would like to create a module import, which will read the data from the source file and bring it into the Python environment. After importing, you typically do exploratory data analysis, which is data quality check. So you will have a module EDA, exploratory data analysis. After having done exploratory data analysis, you want to do some data aggregation. So you have a module data aggregation. From that, you generate some basic MIS reports. So you want to generate a report by geography. You want to generate report by product. You want to generate report by customer segment. You want to generate report by time. So I created a module import. I created a module exploratory data analysis. I created a module data aggregation. I created a module report by geography, report by product, report by customer segment, report by time. So I created 7 modules. This ends up with the output which is consumable by me as a business user. These 7 files, do I place it in 10 different folders or 7 different folders? Does not make sense. End of day, all of them together gives me the required output. So I would like to package them in one folder structure and in one coherent unit. And that coherent unit which makes use of all of these modules, put all of them together, is called a package. So organizing modules in a systematic way is package. What can a package contain? Package can contain sub-package. This reporting can become a sub package of a bigger outcome that I want. After reporting, probably I go to the next step, which is called predictive modeling. So in a predictive modeling, I have a package, I have modules, run regression. I have a module, run model performance measures. So regression becomes my one module, model performance measure becomes my one module, validation becomes a one module to see whether the model is good, validating that thing. So here I have created three modules. These three modules are for predictive modeling. So I've got now a module reporting. I've got a module reporting. I've got a second module predictive modeling. These two modules can together go and become part of a bigger package. So it is like creating a folder structure. I've got some folder structure where one folder would be for reporting. I'm just indicating it by R, and then there would be one folder which I'm reporting it by P, which is for predictive modeling. And this R has got various py files. So it has got many py files, and this folder has got many py files, and this I'll call it as PR, say project. So project becomes the main package for me. R becomes reporting becomes my sub package. P becomes my sub package, and within R I have got modules, and within P I have got modules. So this is a structure which gives you the full high level package. So this way you can structure your codes, your modules, your sub packages and packages. This is the third point which I just explained graphically. Packages allow a hierarchical structuring of the module namespace using dot notation. What it means is, if now I have to access a module M1, let me just name it for convenience M1. If I have to now refer that, what I have to say is PR dot R dot M1, and if anything which is inside that, I may have to start referring it like this: the variable name, the function name. And obviously the moment you see that I have to give package name, sub package name, the module name, and then the final variable name and the function name inside it, it may become a very long code. Definitely, to shorten it, there are various ways of importing modules, which we are just going to see now. But the first is the conceptual element. How is modules package organized in a hierarchical way? So we are now going to create a folder. The way a package is created is typically you create a folder with a desired name. In a package, you have to create a init.py. The way packages are created is you have to first create a folder by the name which you would like to give that package, an app name. In that package, you have to create a init.py file. Init.py is initialization. In that init.py, you have to write down all the modules which are there in the package. Because when you load a package, what gets loaded, the first thing is the init.py. And the moment init.py is loaded, Python comes to know within this package what all modules are there. So the entire laundry list of modules have to be listed in the init.py file. Place all the relevant modules, that is .py file, in this folder. Sub package. If you want a package to have some package, you have to create a subfolder within the main package. And the moment you create something as a sub package, for sub package, you have to create a separate init.py file. Only then it will come to know within this sub package what all modules are there. Okay. So repeat the steps 2 and 3 mentioned above when you're creating a package. Libraries. Collection of various packages is called libraries. So the hierarchy is now very clear. The lowest granularity is a module. Above module you have got packages, and collection of packages is called a library. Conceptually, library and package, there is no difference because a package can have a sub package. So this package, I have got package 1, I've got package 2, I've got package 3, and I put package 1, package 2, package 3 into a super folder and give it name package 1, 2, 3. In that case, package 1, 2, 3 is also a package. Only thing is, technically, conceptually, we say library is collection of different packages. Okay. So there is no difference between package and a Python library. Just in case you want to be correct in terminology, you may say a library is a collection of packages, a package is a collection of modules and sub packages. How we import packages? Now we are going to focus on, as I mentioned, we are not going to create package. We are going to see how to import. We are already been using the import function. Okay. There are 4 different syntaxes to write the import statement. First is very simple, import and the package name. We just now wrote a syntax, import math, or import module name. If it's a file, .py file, it becomes a module. If a package has only one .py file, the module itself becomes a package. Okay. The other syntaxes are from package name, this one, from package name, import sub package, module, object or function. This is slightly complex, so we will use some examples to understand this. The fourth approach is from module name, import object or function. Let us use scikit-learn library to understand this import syntaxes. The 4 different ways of import, we'll use a scikit-learn library. What is scikit? Scikit-learn is the most used machine learning library in Python. Most of the statistical work, most of the regression work, most of the data analysis work, all of the packages you will find in scikit-learn library. Sky is scientific. So scientific kit learning, machine learning, scientific kit learning package. All machine learning techniques are part of scikit-learn library. So what are the key features of scikit-learn package? What libraries it provides? It is a simple and most efficient tool used for data mining and data analysis in Python. Point 1. Second, it is accessible to everybody and reusable in various contexts. When it says accessible to everybody, what it means is it is available as general public user license, freely available, no money to be paid to anyone to purchase this. It is built upon Numpy, SciPy and Matplotlib. Numpy basically is a package in which data is stored in a numeric array format. SciPy, Sky is scientific Python library. Matplotlib, plot, the word, it is for plotting purpose. So matplotlib is a library for graphical plotting, charts and graphs. Finally, open source commercially usable BSD license. Official website is https://scikit-learn.org stable. So this stable, from here you get the stable version. Whichever latest stable version of Scikit is there, you will get it from here. How we go about installing Scikit? Scikit-learn requires a Python which is greater than or equal to 3.5 version. You require Numpy which is 1.11 version or above, and SkyPy which is 0.17.0 version above. And how do you install? To install, you can use either a pip command or you can use a conda command. Where are you going to run the pip command or the conda command? You're going to run the pip command or conda command on the Anaconda prompt. So what we'll do is we'll start our Anaconda prompt, and you have to right click, run as administrator and say yes. And here we will run the command conda install scikit-learn, enter. So here it is collecting the package metadata. It will try to resolve the environment. It will try to find the relevant package from internet and then start installing. It is going to ask you whether later on it is going to ask you whether to install yes or no. So here you can see that it has found the following packages will be downloaded, and it mentions the following packages will be updated. By default, when you install Anaconda, many of these libraries got automatically installed. That is the beauty of working using Anaconda. If we install only Python, only base libraries would have come. But with Anaconda, many important libraries are pre-installed, and many other utilities like Jupyter Notebook, Spyder, those good graphical user interface are also available. That's the reason we are using Anaconda. Let me say yes. So whichever latest packages are there, they will get downloaded and updated. So it is now going to start extracting, downloading the packages to be updated. The installation for this is going to take some time. It is 158.3 MB. In the meantime, what we'll do is we'll go through the background syntaxes of how to go about importing libraries. So the first import syntax, I am saying import scikit sklearn.dataset. So here I am importing a dataset package from sklearn library. Scikit sklearn library, from there we are using a dataset package. Once I import it, I can call functions which are in that package. So there is something called load iris. We can load it. Okay. The next syntax. Here you can see I have written the syntax as import library.package name. Here from sklearn import dataset. This is the other way of writing the same syntax. And moreover, when I use this syntax, I can have additional parameter as something. What it means is from sklearn import dataset as ds, which means I am now going to refer this dataset package as ds. So let me run this first syntax. Okay, because sklearn is being updated in the background, it is now showing star symbol, which means this syntax will not get executed till the full package is installed. No, it was not that, my mistake. It was because it was taking time to load the package. This package is this dataset package has got many datasets which we can use for our own purpose, for our own learning purpose. One of the dataset here is iris dataset, which has got some 150 records of iris species. Okay, so if I show you that dataset, let me run it. Head, sorry. Okay, it does not have the head function because the type, before running that, let us just see the type of iris. It is not a data frame. I was assuming that iris O1 would be a data frame, that's why I was running the head command, but it's not a data frame. So I'll directly show the data iris underscore tab. It will auto complete. Yeah, so this is a data set. Okay, so there is some data which is used for our learning purpose, on which we can try specific machine learning techniques, because scikit is a data analysis package. Now if you want to learn some regression technique or you want to learn some classification technique, you will have to either find data from net or from your company. If you do not have data, in that case you can use inbuilt data sets, and this is one of the data set. Okay, now the same command, we are seeing it as from sklearn import dataset as ds and ds dot load iris, the same command that we saw above. The third command, from sklearn dot dataset import base. Base is a module inside dataset package, and the load iris function is actually part of base. What happened? How come then I was able to run this load iris command using the package name? This is because each package has a init.py file. And what do you declare in init.py? In init.py, you declare all the modules, and sometimes what you can directly do in the init.py, you can declare module and the functions in the module also. Now, if you have declared in the init.py the modules which are present in it and the functions, then directly you can refer those functions from the package name. We will open the scikit-learn package, the scikit-learn library, and we will open the init.py to further understand this. Okay. For now, let me run the last command from sklearn. Sklearn is library. Dataset is package. Base is module. In this base module, you have load iris function. Now I am saying from that library package module, you just import the function. If you just import the function, I do not have to specify the package name or the library name before the function name. I can directly call the function name. This is the fourth syntax. In the meantime, we have got the package skykit completely loaded. So what we are now going to do is we'll open the init.py file of sklearn library. I'll use the term library. We'll open the init.py file of sklearn library and see the details, what is written into it. Yeah, .py, because it is a .py file, I said I'm more comfortable and I feel more comfortable using Spyder. In Jupyter, I would not be very comfortable opening a .py file. So we'll go to Spyder prompt. Let us just open the init.py file. The location where we are going to get it is, first we have to go to your folder where you have installed Anaconda. In my machine, Anaconda is installed somewhere in Python in Anaconda. So first you have to go to the folder where you have Anaconda loaded, installed. In that you will have to search lib. In that lib, you have to search something called site packages. And in site packages, you have to now find sklearn. Because all these packages, when Anaconda was installed, it installed here. So in sklearn, I'm now going to see in sklearn is my library. In sklearn, I'm going to find out init.py. The name of init.py is given as underscore underscore init underscore underscore .py. Init, full form of init.py is initialization. So whenever you load a library, init.py of that package gets loaded first. In init.py, all the details of which all packages are there into it is written. Now this is a complex coding. This is a complex coding. I'm not going to go into the complex coding, but here I want to show you that, hey, somewhere the code is written. Somewhere the code is written here where it is saying which all packages are inside this library. So somewhere we made use of, in our command, dataset. Here what we did is we were working on datasets. So here you can see calibration, cluster, covariance, cross decomposition, datasets. Dataset is a package. Now how can I cross verify? If you see here, these are various packages into it. Dataset is a package. Inside dataset, again you will have to find there is a init.py. If init.py is not there, which means it is not a package. If it is a module, you don't require any initialization. But if it is a package, you will find a init.py. So I'll take this folder path, copy, and I'm going to load that init.py. So probably we can directly navigate from here. Dataset init.py. Now here you see there is a base. In dataset there is a base package. So what is the syntax? From dot base import load breast cancer. It is a dataset on breast cancer dataset. Load Boston, load diabetes, and so forth. Somewhere here we were working on iris. Control F, iris. Load iris. Okay. So here again some coding is there. We will not get into these complex codings. Okay. But what I am trying to say, within init, it is now referring to base module, which is there in the dataset package. Now we'll go into base. So here there are data, and here is my iris dataset. In this dataset, where is my base? This is base.py. A .py file is a module. So we'll open base.py now. Base.py. And here you see the first function is load iris. Okay. So the first function itself is load iris here in this entire thing, because we were in a search mode, so it directly jumped there. But definition, these are functions. Load files, load, where is my load iris gone? Let me once again search iris. Yeah, not the first function, but on the 328th line, this load iris is there. So here the entire code about loading that is written. There is another data, breast cancer data. How do I know that data it is a breast cancer data? Because all the data here. These are the data sets which they have given us inbuilt data set. Okay. So coming back to our Python, now having gone through the entire data structure, we'll revisit all of these syntaxes once again. First syntax, import sklearn.datasets. What we said, sklearn is a library, dataset is a package. I'm saying import the package, which means everything in that package is going to get loaded. Now when I say everything in that package is going to get loaded, which means everything which is here, all of these py files which are mentioned in this init, all of these inits, everything which is, no, this one, this is the datasets init. Everything which is written here, these many import statements are there, all of these will get loaded. Now the point is, if you are not interested in all of them, why are you loading everything in your memory? Because everything is going in your memory. It is consuming memory space, right? So I don't want everything to be loaded. I want something specific to be loaded. Then comes the next syntax, which we are now going to see. The next syntax is from sklearn import dataset. No, again this is same. Here only this one is giving a abbreviation to dataset. It is not loading a specific library. Okay. How do I load a specific package module? From sklearn dataset import base. Now I am loading only base. With this syntax, I'm going to load only base. Otherwise, if I would have imported sklearn.dataset, how many packages would have got loaded? It would have loaded everything: base, COV type, KD, DCUP99, all of these packages and their components in it would have gone into memory. But I am interested only in base. In that case, I say from sklearn.dataset import base. But within base also there are 6 data sets and many other functionalities. I'm really not interested in all the data sets and all the functionalities in that base package or base module. It's a .py file. In that case, you be more specific. From this, import only load iris. By being more specific, what is happening is you are reducing the amount of data, amount of functions, amount of variables which are going into memory. And this is how you do importing in Python. So let us try to summarize what we have discussed so far. We discussed module, we discussed package, we discussed library. Out of the three, which is at the top, library, package, or module? Library. So library comes at the top. So write down library on your notebook. Inside library, what do you have? Package. So write down package. Inside package, what can you have? Package, module, or both? Both. A package inside a package is called a subpackage. Inside subpackage or a package, what is the lowest element that you have? Module. Now coming to the top, when you are at the top, which is at a library level, for example, in Anaconda, all your libraries are actually installed in Anaconda lib site packages. When you install it, all of these libraries are here. For example, sklearn is one of the library. Matplotlib, Seaborn is a library, which then somewhere here Numpy is a library. So you have got many libraries. We were discussing scikit-learn package library, which created a folder sklearn. Now how does Python would know? Because someone has to create all of this. So how would Python, which is getting loaded, how would it know when you are having sklearn? I say import sklearn. The moment I say import sklearn, what all things to import? Which file is going to help the Python interpreter to understand what all it should load when I run the syntax import sklearn init.py. So when you say import sklearn, it is going to search for init.py, and init.py will have some code written in it. That some code which is written into it is this code. This is a complex code. We should not be bothered about it. But this complex code is saying what all you should load. So here it is saying all, many things from import, check, build, and all these things. It is saying you load all of these things. Okay, all of this gets loaded. If I do not wish to load all, because so many things will get loaded into memory, it is going to consume memory space. And it is also going to take time to load. If I do not wish to load all of them, in that case, how do I load a specific package from sklearn library? What will be the syntax? Import sklearn will load the entire library from sklearn import package. So the syntax becomes, if I want to specifically load a package from a particular library, I'll have to say from sklearn import the package name. So this is the first syntax which we executed, or the other way is import library dot package name. This syntax import library dot package name or this syntax from sklearn import package. This is optional. I need not write it. This is optional. ASDS is optional. In case the package I am loading, I want to give some shortcut, some abbreviated name. In that case, what would the syntax become? From library import package as some abbreviated name that you wish to give. Now this is a package which we loaded. A package can have many sub packages and package can have many modules, which means I am having the same challenge. If I load a library, all of the packages gets loaded. If I load a package, I have the same challenge. If it is a bulky package with many sub packages and many modules, again I am in the same crossroad where many things will get loaded into my memory. So what is the solution? So you pull the sub package or you go to the specific module at that point of time, which module you are interested in. So how do I load a specific module from library package, sub package, sub package, sub package? Many levels down the line there is a library module. I am interested only in that module. How do I go about writing that? So the syntax can be two ways. One is import library name dot package name dot sub package name dot sub package name dot the final module name, or the opposite, from library name dot package dot sub package import the module name, right? So this is what we did. From sklearn library we said this package import this module. Now how do I know this base is a module? One, it is init file. So from sklearn we now go to datasets, and in datasets when I check base, actually it is a .py file. If it is a .py file, if it is not a folder, then definitely it is a module, because a .py file is a module. Are you getting? So this is how I can know that it is a module. It is not a package now, because after that you cannot have any file in it. But now again, if this base.py file itself is too bulky, which means someone has written many things in one, instead of, see, there are these many files, these many .py files. Someone is not been efficient and not been very structured in organizing the code. And what the person did is, that person, the content of all of this, logic of all these py files, which I have selected in my Windows Explorer folder structure, he has put everything in this base.py. I'm not interested in everything. Now what? I am interested in a specific function within the base.py file. What do you do? So from package, sub package, sub package, sub package, module, import function name. This is the last syntax that we saw. That here what I did is, from library to package to module, and then from there I just said import load iris. So in that case, everything is not going to get loaded into memory. Only the load iris function would have got loaded. This is how it works. Does that make sense? Is it of help? Does it clarifies many of the doubts? Now with this, try out these syntaxes and let me know if you have any queries. Now let us try to understand the benefit of various types of import syntaxes. Let us first see this import syntax. From library package module import function, which is load iris. When you import in this way, to call the load iris function, I need not type the module name or the package name or the library name before it. I need not prefix all of those here. If you would have imported something like this, in that case the syntax here would have become sklearn dot datasets dot base dot. It would have become this way. However, the way we imported in this syntax was from this full library to package to module. We have said load this function, and if I write it like this, load iris, in that case the syntax would have become li. I'll run this. I get the same output. Because this function I have given a alias li. Okay. So this is how this works. It simplifies the calling statement. Whenever you have to now use that function, you do not have to keep prefixing everything. You can avoid all of this. Okay, I hope this point is now clear. Run the following syntaxes. With this, we conclude today's session on Python modules and packages. Thank you. See you in the next session. Happy learning Python programming.